Hello everyone and welcome to my YouTube channel Data Science 101 where we talk about different topics that are related to data science. As you can see here, today we are talking about regression using machine learning in Python. I'll show you what is a regression equation, how you can solve it using machine learning, um, different types of regression which are linear, reg, lasso, elastic net. So let's get started. In order to understand linear regression, linear regression is shows the relationship between two variables that are one of them is an independent variable and one of them is a dependent variable. So in order to understand it using an example, if I tell you that you want to predict the price of a newspaper, there can be multiple factors included there, like where the newspaper is getting printed, where the newspaper is being distributed, what is the material used in the newspaper, what is the height of the newspaper, and all. So there can be multiple independent variables, and all these factors will contribute to the final price of the newspaper. So this is the basic understanding of how we can understand regression in terms of dependent and independent variables. So if we try to get into more deeper into it, let me show you an example. As you can see on the screen, we have here, we are predicting uh, the average monthly rent for an apartment based on the number of bedroom it has. The data will look something like this, as you can see here. So the number of bedrooms, if the apartment has one bedroom, the average rent will be $800. For two bedroom, it has $900. For three bedroom, it has $1,000, and so on. Now, this data, if you look clearly, or if you create a plot out of it, you'll see that this is a linear relationship because with the number of bedrooms increasing, the price is also increasing at a constant rate. Now, we can create an equation for this particular problem, which will look something like this, which is y is equal to 800 plus 100x. Now, this equation, what it tells us is that the average monthly rent is 800 for an apartment with one bedroom, and it increases by 100 for each additional bedroom, as we have seen here in this. So for an apartment where there are three bedrooms, the average rent will come out somewhere around $1,000, as we can see here. Now, this is what linear regression is. Linear regression can be used to make prediction about the dependent variable. Like I can predict the price uh, for the apartment with six bedroom, which will come around I think $1,300. And also we can use linear regression to understand the strength of the relationship between these two variables, the independent one and the dependent one. So this is all about regression. I hope you understand it. Let's get into the coding and I'll show you how you can solve these linear regression problems using machine learning. So for this particular video, the dataset that I'll be using is the Boston dataset that is freely available in Kaggle. I'll drop a link in the description. You can download it from there. So this data is all about predicting the price of a house in the Boston area depending on certain variables. So let's get started. So initially, if you see here, I have imported all the required libraries. As you can see here, pandas, which is used for basic data frame operations, and also some of the visualization part also. We have imported matplotlib.pyplot and similarly cborn. Both of these are used for visualization. Cborn is based on matplotlib and creates more beautiful and more uh, visualizations. Now let's import these libraries by running this code cell, and the next step will be loading the data. So I have downloaded this data, boston.csv. I'm just using pandas.dataframe operation and reading this as a CSV file, and we'll load it into a variable named as df. And I'll also print it simultaneously here in this code cell itself. Let's run this and see how the data looks. So here you can see there are around 506 rows and 15 columns. This last column, MEDV, this is the median value of the house price. This is the outcome, as you can see, and these are the independent variables on which this particular outcome is dependent. So these are CRIM, ZN, index. These are the, you can see the description of all these columns in the Kaggle itself. You can see what all these columns mean and how they are contributing in this particular variable, how they are contributing to find out the median value of the house. So let's move ahead. Before getting into a model, before getting into creating a machine learning model, the first step should be we should be removing any unnecessary noise in the data, any unnecessary column which is not required there in the data. So as you can see here, this particular column, this is not required. This is just showing the number of rows in the data. So we'll remove this in the next step. As you can see here, this is the command we use to drop the data. We are dropping it, the column name, as you can see here, unnamed 0, axis 1, which means that this is the first column, and in place equal to true. Let's run this. We'll drop this. Let's see the data again. So as you can see here, that we have dropped that particular column. Moving forward, let me show you two more things. So there's a function in data frame operations. We can see here df.head. What this does is it shows you the top 5 rows. By default, it shows you the head one, shows you the top 5 rows. As you can see here, these are the top 5 rows of the data. This gives you a picture of how the data looks like. Similarly, we can see the end of the data also, and this is like configurable. You can add the number of rows that you want to see. So df.head shows you the top of the data, while df.tail shows you the end of the data. And I'm adding like a number 10 here, so it will show me the last 10 rows of the data. Let's print that. So these are the last 10 rows of the data, as you can see here. Now moving forward, the most important thing, the most important statistical properties of the data can be visualized, can be analyzed using df.describe function, which is an inbuilt function of pandas for data frames. If we run this, you see these are the columns, these are the variables that we have in the data, and these are the statistical properties. So count shows the count of the rows. Similarly, what is the mean value of this particular column, what is the standard deviation, what is the minimum value, the quartiles, 25%, 50%, 75%, all of these, and what is the maximum value. As you can see here, this is shown for all the columns. See, now moving forward, let's see what is the shape of the data by running the shape command, and we see that there are 506 rows and 14 columns. Out of these 14s, 13 are uh, independent variables, and 14th one, that is MEDV, that is the dependent variable, and we'll try to predict that particular column, the value of that particular column, by providing the other 13 values. Now the next thing is, let's look into the information. The information is nothing. It shows what the data is, what the data is, what is the data types, if there is any null value or not. So here you can see that there are around 14 columns, and we have float, integer, then again integer and float. So there are, this data set is a combination of floats and integers, as you can see here. So we do not need to change any data type, because we will be using that as a float and integer itself. So now the next step will be, we'll create a regression plot with respect to the outcome column, which is MEDV. So we'll create a regression plot which will have all the columns that are there in the data on the x-axis. Similarly, with respect to the outcome column, which is MEDV on the y-axis. What this will do is, this will help us in analyzing the relationship of every column that is there in the data with respect to the outcome column. We're using matplotlib and Seaborn as well to create this regression plot, as you can see here. And we have set the figure size to 15 by 30. Other properties you can see here. Now let's run this command and let's see what is the output here. So as you can see here on the screen, this first graph is showing the first column, which is CRIM, with respect to MEDV. What is the regression plot for this? Similarly, all other columns are also visible here. So we can see which all columns are, how strongly, or how they are related to MEDV, which is the outcome column. As you can see here, these are the different columns: RM, RAD, distance, age. Similarly, all other columns, all 13 columns, as you can see here. Now, moving to the next step, what we'll do is this is the most important step where we will train test split the data. So, what do you mean by train test split? What we'll do is we have a training set which contains around, I think, 560 rows. What we'll do is we'll split it into two different sets, which is a training part and a testing part. As you can see here, I've did it by 0.3, which means like 70% of the data will be used for training, while 30% of the data will be used for testing. Here we have imported train test split from sklearn.model selection, and how we are splitting it, we have defined four different variables where we are using train test split. And the first thing I have passed is df, all the columns that are independent, all the independent variables. And similarly, the second one will be the outcome. The test size is set to 0.3, which will bifurcate the data into 70 by 30 ratio. Let's run this command. Now, while this command is running, there's one more thing that I wanted to show you here, which is random state. Random state is nothing, just it shows you like how random your data distribution should be. And it controls the shuffling process of the data, as we can see here. Now, moving to the next step, here you can see I'm importing all the required models. So as I told you, we'll be talking about linear regression, ridge, lasso, and elastic net. So I've imported all of them in a single command from sklearn.linear model. Now, fitting that model into a variable, as you can see here, I've defined a variable linreg where I've called linear regression as a function, and I'm fitting the data into this. And how I'm fitting it, I'll show you. So linreg.fit will pass two different things here. First one, all the columns that are independent, as you can see here, and the second column will be the output column. And as we'll run this, the model will be fitted into the linear regression model. Let's run this command. As you can see here, this is linear regression. Now the next step will be we have fitted the model, it's running well. Now let's see what are the coefficients. So coefficients is nothing. We have the command as y is equal to mx plus b. So coefficient will be, and in that equation, m is the coefficient that will print here. Let's see what are the coefficients. So here you can see these are the coefficients. Y is equal to mx plus b is the equation. Now the next thing that will print is the intercept. Now intercept is the value of y when all x are 0. So in the equation, y is equal to mx plus b. When x is equal to 0, what is the value of y? So let's print this also. As you can see here, this is the intercept, and this is the final where we will run this model on the training dataset and see what is the score. So score is the accuracy, like how accurate we are predicting. If we run this, it gives us 0.74. So the model is 74.29% accurate on the training set. Let's see how it performs on the test dataset. We'll run this and it comes out around 0.73. So this is how we do linear regression using machine learning model. As you can see here, this is very simple steps. You just need to fit the data here as I showed you. Just run this. We can see the coefficients, the intercept, and just run the linreg.score, which will give you the final score of your model, and similarly on the test dataset also. So this is how we do linear regression. Now in the next phase, we'll learn about what is lasso, ridge, and elastic net regression. So let's jump into that. Now let's talk about lasso regression. So lasso regression is a way to build a linear model that is more generalized towards new data. So whenever we pass a new data to the model, it will be more generalized towards it. How it does it? So what it does, it selects only a subset of the features that are more important to the model, to the outcome that we are predicting, and it shrinks the coefficients of all other variables. So which in turn lowers the overfitting and helps in achieving more accuracy in predicting the target variable, as you can see here. Now how we can do that, as we already imported lasso in the previous steps, I'll just run this command. So I'm creating a variable named lastReg where I'm taking the lasso function and also fitting the data at the same time. As you can see here, we'll just run this. So we have created the function for lasso. What we'll do is we'll again check the coefficients and the intercept. This is an optional step. Just if it's not required if you don't want that. See, these are the coefficients and these are the intercepts. Now similarly, we'll test the accuracy here for lasso regression. Let's check it for both training and testing dataset. It comes around, training is 68.43, testing at 68.18. So model is not overfitting because we have similar accuracy for both training and testing dataset, but it is quite less than the linear regression. So we can discard it. Now, moving forward to ridge regression. So what ridge regression does is this also helps in making the model generalized to new data. But how it does it? It does by adding a penalty to the cost function. So what penalty means? It just lowers down the coefficient to zero, not exactly zero, just lowers down to make it near to zero, and it helps in reducing the complexity of the model and make it more reliable on new data. Let's run the command for this also. We have already imported ridge in the above commands. Let's just fit the data into ridge model. Let's check the coefficients in the intercept. These are the coefficient and intercept, and similarly let's print the accuracy. See, this accuracy is much better compared to lasso. As you can see here, training is 74.2, testing it's around 71.4, maybe a little overfitting, but we can always work on training the hyperparameters. Now the next thing, elastic net, this is the combination of both Reg and Lasso. So it penalizes in two ways, L1 and L2. It selects a subset of the features that are there in the data, and it also lowers down the coefficient of other variables that are not that important. So it combines both Reg and Lasso. So let's see how it performs on our data. We have already imported ElasticNet, so just putting it into a variable named ELA Reg and fitting the data into it. Let's see the coefficients and the intercept. Let's print out the accuracy here. The accuracy is not that good, but if you see, this is more robust in terms of this has less complexity and less overfitting here. So this is how you can perform linear regression using different methods. I showed you what is linear regression, how you can fit your data into a linear regression model, how you can create different models like Reg, Lasso, ElasticNet. In the next video, we'll talk about the classification problem. This was more into regression problems. Next, we'll talk about classification problem. I'll drop a link to this Jupyter notebook in the description itself. You can go through it. Please mention any problem that you face while running this, while understanding this in the comment section, and I'll go through it and reply you. Also, please do like, subscribe, and share this video as it will help me in creating more content for you. Thank you so much. Let's meet in the next video.